In this video, we're going to go through elementary reactions, and I'm going to explain the process for reaction mechanisms and how those work. So let's begin by defining an elementary reaction. So here we have an example of a reaction. Okay, so we have 2 moles of nitrogen monoxide. Those are going to combine with oxygen to make 2 moles of nitrogen dioxide. So in a perfect world, everything all happens at the same time, and boom, you've got a product. But it's really unlikely for that to happen in one single step. So this reaction actually occurs in multiple steps. Those are called elementary reactions. So step number 1, we have 2 moles of nitrogen monoxide. Those are going to combine, and those are going to form N2O2. N2O2 will then combine with oxygen to form the 2 moles of nitrogen dioxide that we want. Okay. Now, I want you to notice in the reaction here, we have dinitrogen dioxide as a product in the first reaction, and it's a reactant in the second reaction. Okay, we'll come back to that. That's called an intermediary. Okay, so reaction 1 and reaction 2 we can call elementary reactions. So those are 2 steps that we need to have our reaction take place, the one that I circled up here at the top. All right, so as I mentioned, our net equation, the equation that we wanted, was a combination of our 2 reactions that occurred. And again, dinitrogen dioxide was a product in reaction number 1, and it is consumed in reaction number 2 to make our 2 moles of nitrogen dioxide. We can cross those out because it's made in the first reaction and then it's consumed in the second reaction. So it's there for a second, but then it gets used up really quick. We sum up the 2 elementary reactions, the 2 elementary steps, and we get our overall reaction, our net reaction. Okay, now going back to rate laws can be inferred from an elementary step based on the number of molecules that must collide. So I need 2 moles of nitrogen monoxide to combine to form our dinitrogen dioxide. Since I have 2 moles or 2 particles, 2 molecules of nitrogen monoxide that have to collide, it is a second order reaction. And if we were to write that out with the rate law, it would be our rate constant times our mole of dinitrogen dioxide, and then our oxygen. Those are each to the first order. If I combine those 2 things, that would be 2. So 1 plus 1 equals 2. All right, molecularity describes the number of molecules that have to collide in an elementary step. So unimolecular, you have 1 molecule. Bimolecular, you have 2 molecules. Intermolecular would be 3 or more molecules. So unimolecular would essentially just be decomposition because it is breaking apart. All right, here we go. Imagine you work in a chocolate shop. It takes you 15 minutes to make a chocolate, 8 hours for it to cool, and 5 minutes to box up the chocolate. Question is, which step of the process limits how fast you can make a chocolate? Well, 8 hours for our chocolate to cool is crazy. I'm going to be sitting around and waiting for it to cool for a very long time. So that step in the process limits how quickly I can make the chocolate, because it only takes 15 minutes for me to make the chocolate and 5 minutes to box it up, but 8 hours for it to cool. So that would be our limiting step. That's the weakest link in the process because it takes the longest amount of time. Okay, so this is what I essentially just said. The slow step of the reaction determines the rate of the reaction. If the first step is slow, the overall rate for the reaction will be based on the stoichiometry of the first elementary reaction. So here we go. That's our first step. It's a slow step. So the overall rate is going to be based on our first reaction. So when I go to determine my rate law, I use the first reaction to determine that rate law. because that's our limiting step. If our subsequent step is slow, then you have to add up all the reactants to the slow step and cancel any intermediates to determine the rate of the reaction. So our second step here is the slow step. So I'm going to combine the two reactions. So if I did that, I would have A plus B plus C on the left side of our reaction. And then on the right side of our reaction, I would have B plus D. Now, on our reaction here, I have B on both sides, so B can cancel out. So I'm left with 2A's, or A squared, on the left side, along with our C right here. And that is where our rate law comes from. So if your first step is the slow step, you just use the first step to determine the rate law. If any other steps are the slow step, you have to add up the steps to the slow step and then cancel out any intermediates to determine your rate law. Okay, so here's an example. It says, given the following elementary steps, what is the overall reaction and what is the rate law for elementary step number 1? So if you look at the equation here, H2I2 is present in both reactions. It's present in both reactions. That's an intermediate. So I can eliminate that from the overall reaction, okay? Because the question is asking us for our overall reaction. So I'm going to now add up the left side and the right side of our reaction, but eliminating our H2I2. So on the left-hand side, I would have 2HI. And then on the right side, I'm going to have hydrogen and iodine. That would be our overall reaction. Now, the rate law for our first step, so step number 1, to determine the rate law for the first step, I have 2 moles of HI. So my rate law will be rate constant. Now I have 2 moles of HI that need to collide to make the reaction, so that would make it to the second power. All right, example 2. It says gaseous cyclobutene C4H8 breaks into 2 gaseous ethylene C2H4 molecules via a single step unimolecular reaction. Okay, so again, decomposition. Write the balanced equation for this reaction and then write the rate law for the reaction based on the stoichiometry of the first step. So again, this is going to be decomposition. So C4H8, because it's unimolecular, and it breaks apart into 2 gaseous ethylene. Forgot to include the state of matter here. And it's asking for the rate law for the stoichiometry of the first elementary step. We really only have one step here. So on the left-hand side, we just have C4H8. So our rate law is going to be K. And then it is going to be to the concentration of C4H8. That would be to the first power because there's only one of them. And that's it. So those are the basics for elementary reactions. Again, elementary reactions are the steps that need to happen for an overall reaction to occur. Any species that exists as a product of one reaction and then a reactant of another is an intermediate. And those can be eliminated when we write out our overall equation. And that's elementary reactions.